Hey everyone, it's Colin. How's it going? In the 1980s, audio cassettes were incredibly popular, but there was another tape format that was poised to replace them. This time, let's see what it takes to fix up one of those decks. This is a Sony DTC690. It uses a format called digital audio tape, or DAT. I've previously done a video about how DAT works and its history, so be sure to check that one out if you want the full story. But put simply, it offered CD quality digital audio. And out of piracy fears, the US recording industry managed to more or less kill it in the consumer market by the early 90s. I bought this unit with the problem description that the tape door didn't work. When powering on the deck, the display indicated that it was already open, when clearly it wasn't. Pushing the eject button did nothing, but I was able to manually open the door by hand. A quick look through the service manual showed that the door is driven by a belt, and given my experiences repairing other tape players of a similar vintage, I figured it had simply deteriorated over time. But in this case, I was very wrong. The top cover is held on with just a few screws along the sides, then I could lift it away. The belt is on the left side of the tape mechanism, and to my surprise, it seemed fine. What appeared to be the problem was much simpler. This cable had been disconnected from the mainboard. Tracing it back, it led to the motor that drives the belt, along with this small PCB containing two limit switches. They tell the deck whether a tape is loaded or not, so with no signal from them, the deck assumed the door was open. Before I could reconnect the cable, there was another problem I had to fix first. I disconnected the other cables coming from the tape mechanism, then removed the 4 screws that held it into the chassis. And here's why. This stabilizer bar had somehow lost a screw on one side, and the screw that remained on the other wasn't tight at all. Between this and the disconnected cable, it was clear that someone had been messing around inside this deck. So much for a simple repair. To get easier access to the stabilizer, I turned the loading gear by hand to put the mechanism into its eject position. That exposed the bracket the bar needed to connect to. The hardware store didn't have any screws in the right size, but I was able to find an eyeglass repair kit that did. I got the stabilizer reattached to the left side of the tape tray, but that just exposed another problem. It was now crooked. One side of the loading mechanism has 2 plastic arms that hinge against each other, but on the other side, they were loose. I adjusted the hinge pin back to where it belonged, and that fixed it. The stabilizer was even again. Since the belt seemed perfectly fine, I put the mechanism back into the deck to test it out. When I powered it on, it no longer said the door was open, and the eject button actually worked. But when I loaded a test tape, yet another problem presented itself. The deck would pull the tape out to wrap it around the drum, but the guides would then immediately retract and the tape would stay slack. It would try this a few times, then stop and show a caution message on the display. So I carefully fished out my test tape and got back to work. The tape guides are accessed from the underside of the mechanism. After unscrewing the motor control PCB and spindle assembly, everything initially looked okay to me. The guides are moved by gears that ride against this slider mechanism, and both of them were working fine. But on closer inspection, I noticed that while one of the gears had a retention clip, the other one was missing. When installed in the deck, these gears would be upside down, so the clips are necessary to keep them from falling out due to gravity. And that seems to be exactly what had happened with the guide on the right. Its gear was misaligned on the track. Finding a replacement clip seemed like it would be a daunting task, so before jumping down that rabbit hole, I decided to try to make one first. In Tinkercad, I designed a simple copy of the original clip. The resulting 3D print looks reasonably close, but it's clear that I'm pushing the boundaries of what my printer can handle in terms of detail. This thing is only 4 millimeters across. Yet, to my surprise, it snapped onto the spindle perfectly and seemed to be holding well. Perhaps there's more opportunity for small 3D printed replacement parts than I had realized. The tape guide assembly seemed to be working correctly now, so I put everything back together and tested it out again, just to find that it still didn't work. The guides kept trying to load the tape and then would immediately retract. Some more diagnosis was in order. I noticed these springs on the slider assembly. They attach to the tracks the gears ride along. Pushing the slider to the left extends the guides, but with some extra effort, it could move a little further. Underneath the slider are 2 limit switches that tell the deck its position. The second switch only gets engaged when the slider has been pulled against those springs. The tape spindle assembly has a motor with a gear reduction setup. This engages with teeth on the slider to move it back and forth. When the second switch is engaged, the motor stops and the deck activates this solenoid. It pushes an arm that unlocks the spindles but also drives a rubber bumper into one of the gears to hold the slider assembly in place. This is a clever bit of engineering. Even though the slider requires a decent amount of force to pull it against those springs, the gear reduction setup makes it easy for the motor. It also means a small bumper like this, in the right place, is plenty to then keep those gears from turning. I came to the conclusion that the problem likely wasn't mechanical in nature, but rather electrical. If the slider never moved far enough to trigger the second switch, the deck might abort the tape loading process. And indeed, when I put the deck back together, it seemed like the motor would struggle to move the slider that last little bit. It's almost as if it couldn't generate the torque necessary to overcome the springs, despite the assistance from the gears. Some research online suggested that I check out the main board, which contains the power supply circuitry. I disconnected all the cable assemblies, then removed this bracket that secures a pair of power transistors to their heatsink on the back panel. Then I could carefully unclip the board from the chassis and lift it away. And almost immediately, I found the problem. One transistor was still firmly attached, but the other was very loose in the PCB. I flipped it over to find that the solder joints for that part had all become broken. This transistor would have worked intermittently at best, and definitely could have caused a voltage rail to be weak or missing. I reflowed the joints with fresh solder, then took a look at the other transistor. It was developing cracks too, so I got it reflowed as well. So why did this happen to begin with? Since these parts are mechanically coupled to the chassis through their heatsink, if the deck had seen rough handling, the solder joints would have been the weak link. While this DAT deck doesn't look beat up, it isn't perfect cosmetically either. I don't know how many hands it's been through since I got it, but assuming it might have been dropped at some point seems like a safe bet. Leading further credence to this was another problem I noticed. Most of the front panel buttons felt fine when pressed, except for the stop button. It seemed like it wasn't engaging the microswitch behind it. I looked at the back side of the front panel and found that the corresponding corner of the circuit board wasn't clipped in properly. To fix it, I needed to remove the front panel entirely. I took out the few screws across the bottom that hold it on, along with some cables for things like the front headphone jack, recording level knob, and button controls. At that point, it simply unclipped from the chassis, and I could start taking out the screws that held the PCB to the faceplate. I was concerned that perhaps the microswitch itself had been broken, but I was relieved with what I found once I got the PCB flipped over. The switch was still there and seemed to work just fine. So the deck likely had gotten dropped, which would have caused the PCB to pop free in that corner and keep the stop button from making contact. With everything back together, that button now works just like the others. So does this thing load tapes now? I dropped in my test tape and crossed my fingers. Yup, it was those transistors all along, keeping the motors from working properly. The question then became, would it play audio? I swapped the tape for one I had recorded a while back and pressed play. Another problem? The audio was heavily distorted, but it sounded more like a digital issue than an analog one. Looking this problem up revealed a thankfully simple fix. The tracking on DAT tapes is apparently pretty unforgiving and can lead to results like this. I simply needed to carefully adjust the tape guides, which would change the alignment of the tape with the drum and get things reading properly. And finally, after all those problems, I ended up with a DAT deck that works. Now, having been dropped could explain some of the problems I found, but what about the whole tape door not opening thing, or that missing plastic clip on the tape guide? Well, the auction listing for the deck might explain it. There's a note here referring to mini DV. I suspect someone mistook this for a video player and tried to load a mini DV tape in it. They're a similar size to DAT, but mechanically incompatible, so if the tape got stuck inside, they'd have to disassemble the deck in order to retrieve it. And if they don't know the difference between DAT and mini DV, they may not have known or cared to put this thing back together correctly. But as they say, all's well that ends well. Ultimately, this is a pretty decent DAT deck from around 1993. In addition to analog inputs and outputs, it also has both optical and coax digital connections. This would have been a mid-range model in its lineup, but came well after DAT deck manufacturers had given up hope on consumers switching away from analog tapes. By then, Sony had already launched a very different format in hopes of replacing both DAT and cassettes. But that's a story for next time. If you liked the video, I'd appreciate a thumbs up and be sure to subscribe. You can follow me on social media at thisdoesnotcomp. And as always, thanks for watching.